Okay, here we are again. Welcome back on our little Convember session. It's Convember number 26. We're live on Instagram and Twitch, and we're trying to iterate over body. In fact, it's body interpretation. This is body interpretation number 26. So let's look at the one we've made yesterday. So yesterday we've played with these little guys here. So the main idea was to creating a man made of Lucky Charm, and the Lucky Charm was some Daruma dolls with various color, etc., etc. And it was some kind of an excuse to try to simulate some collision between the dolls, and to do that we basically use a separation behavior in our physics systems. So yeah, this is our little guy here. So look like the dolls are colliding on each other, so I'm moving. So they basically attract to a vertex element. So yeah. So what can we do today? I haven't thought about it, in fact, today. We made a lot of different experiments, and I thought it might be interesting to bring some, I don't know, maybe some, to continue this behavior, and maybe to bring some alignment and cohesion to this in order to create some kind of a flow field, you know. So maybe we can have a guy which are walking, and there is some elements which has some kind of a flow field of simple elements. I think I will go with a simple geometry for this one, and then it will go also to the target. So I think that might be something interesting. So yeah, let's try to look into it. Okay. So first of all, let's save everything as 1126. That's okay. And we would need to duplicate all the elements. So first of all, we duplicate the material, we duplicate the compute shader, we will duplicate the instance shader, we'll duplicate the controller and the GPU mesh controller. Okay. So of course we cannot put this right away because we need to correct the elements here. So let's correct this a little bit. So this is 26. This is the controller. Let's take the GPU mesh controller, which is now at 26. I will take also the compute shader, which is 26. I will take in the shader parts the instance surface, which would be 26 also. For the surface, let's start with the surface. In fact, a rough material metal normal. We will get rid of the atlas right now, so we won't use it anymore. So basically we will simply use the RGB multiply by the in.color, and I just seen that we haven't used the multiplication by the in.color. In fact, we could use we could use it yesterday, but we haven't used it, so that's not a problem. But let's also try to simply comment this so we haven't needed. So this is the compute shader, this is the instance surface shader, so everything seems to be right for me. Okay, go back to that. We need to put a controller here, so let's remove this one. The GPU mesh controller also I would put on the top. 50 elements, 500 elements, sorry. Let's set a simple. So what kind of mesh could we use to test anything? You know what, let's try the cylinder for a moment, because we have some kind of an orientation on that. With a mean scale of 1 1 1 1 1. For the material we put the 1126, and let's use that. Compute shader 26, and now the ramp 1D we will use the third. Okay, I also need to change that part because we're using the shader from yesterday. Okay, and let's use a simple material, and for example let's use the T-Razzo. Yeah, we will use the T-Razzo black and white, so this, and we would take the ruggedness and the reflection mask, and I think that's it. Let's try to see how the shader behave on the sphere with this 1119. Of course. So I need to change the size for that. Okay, now this is okay. Let's try to change a little bit this material. A little bit too white, of course, but we need to put some thing like maybe that might be interesting. The reflection mask seem a little bit odd. Maybe I could use the same. No, it seems interesting. Okay, could use the same. This, for example, we could use the displace as the metallic. This could be also interesting. What happens if we use the true color with the red zone? Whoops. Okay, so that's for this part. I can get rid of this one. Okay, here we are. I think I will change that but by something else, so let me change this a little bit. Let me think about that. First of all, yes, we have this. Okay. Yeah, I think I could create a new things on Cinema 4D. So yeah, let me explain what I had in my mind. So basically, using cylinder was quite interesting, but not enough. I think it's been more interesting to use some kind of a parallelepipedic shape. So taking a cube and elongate some of its face in order to see the rotation and the direction. So for example, if we are flocking, so I want to see the elements going, so if it's a line, it's more easy to show. So I could use a cylinder, but if I use a cylinder, I will not be able to distinguish the way it's on itself. So having something with some kind of facets might be more easier to define the rotation, to see the rotation. I could use a cube and try to extrude it directly using the model scale here. But remember, when we try the separation, we take the bonds of the mesh, which is not related to the scale, but it might be working. In fact, let me check. If we use a cube, now we will have little cubes, so that's okay. And what's happened if I say I wanted to in this? So no, it doesn't change anything, even if we have a model description here. So that's range because the scale is put in here, so, and we multiply the range by the model description, so it should work. And of course it will not work because we're redefining the size directly into the compute shader, so that's why it's not used that way. So you know what, let's try to use that without using Cinema 4D. So for that I would need in the compute shader to pass my value. So in which element I could pass this value? The oppose is already used, you know that. But we have something interesting we have the origin scale matrix. Remember, the origin scale matrix was at first origin, so it was this origin scale mat. So the origin scale matrix, we simply push here. It was the rotation here, but we didn't need to use it anymore. We can go back to the origin scale matrix, and the main idea would to be simply save the original scale. But instead of saving the original scale, I could save the model description. I think that would be better. So let's try that. And now I can retrieve this model description by saying flow3 model desk would be something like flow3, and we need to take on our matrix the value which is on the line 0 colon on the row 0 colon 0, row 1 colon 1, row 2 colon 2. Yeah, I was closing my eyes because it's easier to me to pictures the matrix. So yeah, so this is the first component, the second component, and the third component. Then this one could be basically push here. So this would be this multiplied by the ramp. So here it is, we have the basic scale system multiplied by the model description, and this could give us an elongated cube. Oh, I have an error running in the compute shader, which is, what is it? Model desk, it's a flow3 ramp is not used, it's a float. So let's go back to that. So now it's scaled. So I'm not sure if it's scaled in the, it seems to be scaled in the proper direction, but I'm not sure about that, what it looked like. So we could try to reduce a little bit this size. Okay. So it's basically working. So let's go back to something simple. Okay, it's not perfect, but this should be our little guy here. The first thing first, I think I want to simplify a little bit this part in order to put everything into some, you know, some function here. So let's try to say we want two functions. So we want the float 3, which is the seek. So it's a seek behavior. I want to have a float 3 target. And this will return a float 3. And we would need something like a float max force, a float max speed. Okay, and we could say something like that. Let's take this little guy here. Okay, and let's return the steer. So this is the seek. So we could say something like float seek is equal to, so seek2 is equal to seek to the position buffer at the index, which is basically our target, and we will use the min max force. I think this is this, we've used that. No, yes, we use that. So min max force and min max speed. So now I need to change this a little bit. So target minus position. I need also to pass the position if I want to. Yeah, I need various things. I need to pass. I need to pass nearly every variable. So this is a float 3 for the target. So we would have the target, the position, and the val. Okay. So seek the position and the val. Okay, this part should work. And the clarifier min max force. Here it is, and the max speed would be here. And the clarifier steer. Oh yeah. Ah, I've created a vector for that. Is that so? No, it's not. Where do we find the steer value? And if I ask steer at compute shader 127. Oh, it was a there was a mistake here, which is quite strange also. So yeah, let's call this steer. Okay, so we should have the same thing now. But we have the separation, so I think this is because I've changed this part. Absolutely not. This is kind of strange. If I put everything into Does the separation make something different? Yeah, as you could see, it's clearly we have clearly an axis problem. Float position, vel. Yeah, it's a float. That's one. And now it's working. Okay. So the steer is okay, and now that I'm rereading what we made yesterday, I thought that we haven't used the curl. Compute it, but we haven't used it. So now we have the separation, and I will need to put all this little thing into a separation function. So again, let's use all of that, and let's name it float3 separate. Okay. So value thing, the sep is here, max instance, we can state this here, properties declare on the top, so not a problem. Maple also, ramp also declared, this is also declared. So I will need to say float3 position, of course. So I've used this one, position, diff count plus, if count, and I need to pass the velocity, so float3 vel, and I think I will need to pass this little guy here, so the min max speed. Do we have another thing than the min max speed? Yeah, I need to pass the two. So float max force and float max speed. Let's put that max force and max speed here. Okay. This should be a correct float3 sep is basically equal to separate of the position, the velocity, the min max force, and the min max speed, which is here. So we have the steer and we have the sep. Identifier ID. So yeah, I need to push the ID, of course. So let's say int ID. So I will not to recast it. It's a U. I think I would need to, yes, yeah, I do not need to recast it. In fact, I would simply say something like id.x no, for me it seems okay, and size, of course, I need to push it, so float3 size, separate no matching overloading function. That's right, because I haven't pushed the size here. Forward semicolon. Not all paths return. Yeah, I haven't returned the sep value. And if it's okay, we would have the same behavior. Okay, that's cool. Let me just grab another cup of tea. So waiting until the water is ready. Okay, so this is what we've got yesterday, and now I wanted to try some kind of flocking. So what is flocking? Basically, flocking is this. So what is it? It's basically a behavior described by Craig Reynolds in early 80, I think it's in early 80, and it describes the behavior of what Craig Reynolds called a void. So it's meant to simulate the behavior of flocking birds, and in order to simulate that Craig Reynolds proposed 3 behaviors which can work together to have this kind of global neighboring behavior. So the first rule is the cohesion. So the cohesion is, if you take void, it will try to get closer to other voids. So it will look for the nearest void and try to go near to them. So that's the cohesion. Then we have the separation. So even if I want to go close to the void, I want to maintain a certain distance in order to avoid to collide with him. That's the separation. And then you will have the alignments. So the alignments tells that the voids can also try to follow the same direction than the neighbor. So that's how we get this kind of aligned voids which flux around that. So this is the example from Daniel Schiffman, the implementation of Craig Reynolds void behaviors. If you want to know more about that, we could simply go back to the original website of Craig Reynolds, where he described this behavior. It's basically voids are one of the main systems involved in simulating natures, in programming graphics, and in game design. So bird flocks, it's really interesting. So this is the website describing the basic behavior. So you will see the 3 behaviors. So the separation, first of all, we try to steer avoiding the neighbor in order to stay at correct distance. So we need to define this distance. We have the alignment, so we steer toward the average heading of local flockmates, and we have the cohesion, so we steer toward the average position of the local flockmates, so the behavior. Daniel Schiffman described its implementation really simply by taking the voids and trying to look over the nearest voids around that. But you can add a lot of different behavior, especially you can add a vision to our voids. So the if you want, the void can only see along a certain angle and to a certain distance. So in that way you will have some kind of more realistic void, because now if you want to simulate a bird, it seems a little bit normal than a bird cannot see behind it, or it cannot take consideration of all the flocking voids around them. So let's first of all check the nearest one, and then we will check around them the alignment, the cohesion, and the dispersion. We will not try this vision system, we will only focus on the simpler implementation. We could also add some collision detection. So the main idea is to try to avoid cylindrical obstacles, and this is really kind of simple to for the boys to know their environments. You can push a ray and march on this ray, which is basically the velocity, and try to find if you hit any obstacle. So it's really simple. So yeah, this behavior is described in I said in the early 80s, so I was not wrong, because it was in 1986 that is modeled this system. So yeah, so basically the cohesion, we don't have the cohesion, we don't have the alignment, so we need these two behavior, but we have the separation. Right now we only have a separation and a steering behavior to a target. So the target is basically the position of our of the vertex we want to follow, basically. So that's the system. So maybe we can try to make something modulating in time. So sometimes it flocks, sometimes it go to the target, sometimes it flocks, sometimes it go to the target, etc, etc. I'm not sure I will be able to have some time, because I'm seeing that it's nearly 22, so I'm not sure I will have the time to put some real 3D into it, but at first the idea was to put some butterfly into it and try to have some butterfly with flapping wings. So maybe we will try to do that tomorrow. Simply add to the same behavior our butterfly with the vertex animation texture. So that could be a nice trick. Okay, so let's check our so in the Daniel Schiffman implementation, if you want to break down this a little bit, you have basically two functions. The first one is a flock.run and a flock.addVoid. So we will have two classes, a class flock, which is basically a particle system, and the particle system simply run a function with where it pass the void. So the void is basically the array which can which take all the voids, in fact, and everything goes here. So let's try to look into the run method. So where is the run? Yeah, this is the run in the void. So for the run, it has four function. I said 3 because I didn't take consideration of the last one, which is basically the rendering. The first one is taking the flux, so this is the Craig Reynolds behavior. The second one is the update. We know the update, it's pretty simple. It's the velocity at the acceleration, the velocity limit the max speed, the position at the velocity, and the acceleration multiplied by 0. Again, I'm using an earlier implementation of the physics system. I know Unity, I think Unity is based on Verlet physics and not on earlier physics. I know that Verlet might be more accurate. I've used it sometimes, especially with library or with Unity, but I haven't made my own Verlet system. So this is something I want to dig, but not tonight, because we don't have the time. So we will again work with the earlier physics. So if everything happened in the flock method, let's check the flock method, which is here. So the flock method basically take these 3 vectors. So the 3 vectors are computed here. We know the separation, so we have made this. So the vector is basically aligned is basically an align method and a cohesion method, and then we have some scaling, some weight factor in fact. So if you want to add more separation, if you want to add more cohesion, if you want to add more alignment, we can tweak these three value to get a completely different behavior. And then we apply the force, so basically it's acceleration plus the alignment plus the separation plus the cohesion. So we would need in fact to simply implement the align and the cohesion method to our compute shader. So that could be, I hope, pretty simple. I hope that would be the case, but you know why sometimes we hit a wall when we try to implement something, so meh. Okay, so let's try to implement the align. So how does align function in, there it is. So this is the align method from Daniel Schiffman. So basically we're taking in parameter the buffer with all the voids, with all their position, their velocity, etc. So we would have strictly the same thing as the separation method as we made. So we have a neighbor distance, which is the distance, I think the alignment, the neighbor, yeah. This is the minimum distance between two voids. Okay. We have a sum vector, so basically because it's an average we need to have a sum. We have a count, we need to count the number of elements for the alignment, because it's an average vector, so we need to divide by the number of counts. So we take all the voids, we take the distance between the position and the position of the other voids, and then if this position is bigger than 0 but less than a certain value, so if we are in the range, we could align with the other. So that would be something like sum dot add the other velocity. So we only try to get the average alignment, and the alignment is basically the going toward the velocity of the other voids or the neighbors. So we take the sum and we add the velocity of the neighbor and we count, and if the count is superior than it's bigger than 0, then we divide this vector by the number of elements, normalize it, multiply by the max speed of course, and we compute our steering behavior, which is basically the sum minus the velocity to get the proper steering behavior. If not, we will return a vector of 0 in order to say you don't need to align, so add a force of 0. So this is the alignment. And for the cohesion, it's nearly the same. We still have this neighbor, the sum and the count, because again it's an average. So we have this little system. So for all the void, again we compute the distance between the void and the other, and if this distance is bigger than 0 and less than this the limit distance, to the sum we would add the other position. So remember, this is the equation, so I need to know the average position of the void where I want to go, and if it's if the count is superior than 0, we will divide the sum by the count, and this is a vector that we would pass to the seek method in order to get the proper force for that. As you may notice, there is a way to optimize everything, because in this system Daniel Schiffman implement each method separately. So you have an alignment, separation, and an alignment, a separation, and a cohesion, and for each of them we will have to pass through the for loop. So I know this is really not optimized, but it's help to understand the three behavior. So I will implement it the same way, but you can notice that a way to optimize it would be simply to create a float method with one for loop, and in this one for loop we could simply compute each sum vector for the sum align, the sum cohesion, the sum separation. Again, we are on a compute shader, so we can use the power of our little GPU, and also we don't have too many elements, so we have nearly 500 elements, which is I think can be handled by the CPU, but on the GPU I think it would be quite easy to handle the multiple for loops. So that's for the explanation on the flocking system. So times to try that, and before that, times to reach for a new cup of tea and just see you in a moment. Okay, let's try to implement everything. I've kept, for the one on Instagram, you will not see that because I don't have the space for showing everything on the screen. But for the one on Twitch, you will notice that I will keep the processing implementation on the right and the compute shader implementation on the left, so you could follow my way of getting the Java implementation from processing to the compute shader in Unity. And I think Unity might have crashed or not. Let's cross the finger. It doesn't seem to have crashed. It has a little... yeah. Okay, that's okay. Let's cut. So yeah, it's okay. Let's go back here. Let's keep this. So I would like to create the alignment. So let me just... I think we will need something. So let's create this. The comments here are really not interesting. Another way to optimize it would be to optimize everything would be to change this value in the num thread, because basically now I'm computing everything in the same thread. So this is basically a dispatch. You can dispatch everything along this. I've tried to use it on 1 dimension, 2 dimension, 3 dimension. It doesn't seem to affect the performance, but it would be better to, if you want to optimize with million of instances, for example. But let's focus on basically the experiment. So we want the float 3, which is the align. So let's say align. We will basically have the same thing. We need the ID, the position, the val, the size, the max force, the max speed. So the things that we don't need is, I think, the size, because the size was was put here in order to say, yeah, we wanted to put the size because we wanted to compute specific size in order to have a separation based on some kind of collision on the last one, but now we can get rid of this part. So yeah, we want various things. So float, we want to mean distance. Okay, remember we had some kind of a small system, so we need to keep it small. So let's say something like 0.5 because we are between 0 and 1. Let's say a float 3 sum again. This could be a float 3 0 0 0, and I would add something like float count, which is the number of elements. Okay, now I can use this part where I basically taking everything we want. Okay, and we will simplify it a little bit. So if and if, okay, and for that we need the position, and we need for the alignment the velocity. So we will need the transfer matrix of our neighbor. We don't need the original position of our neighbor. This position is basically this part. We need the index of, do I need the name index? I'm not sure we would need the name index, and we haven't used it. So okay, this one is not interesting of. Now that we have the position, we could say if this is strictly bigger than 0, and if this is strictly less than our main distance, okay, then we would have something like the sum that would basically add our little navel, and the count will increase. After that, if the count is bigger than 0, so if we have any elements, we would take basically the same thing here. So I could say something like that. I will divide it by the counts, I will normalize it, I will multiply by the max force, and I need to compute a steering behavior. So the steering behavior is, so it's not the step, is this. Okay, so divide, multiply, and now we would have something like float 3 steer is, okay, so steer is basically I would say the velocity minus the sum minus the velocity, so target minus location. So this is what we want, and of course the steer need to be limit, so that's our limit. And if it's not the case, we could return this float 3. So let's say that float 3 return float 3 0 0 0. Okay, and now let's return the steer. Okay, so undeclare this, I might say this instead of this. Okay, and if we are correct, which is not, we have something like called min dist, which seems to be not the same way as this one because I forgot to capitalize. So yeah, we have that. We can try the first one. Okay, so let's say float 3 RE, and it's a float 3 of course. So float 3 align is a line of and we need to get the ID, the velocity, basically all these things here, but we don't need the size. And we could say something like acceleration plus equal the li vector. So in order to see if it works, I will get rid of the, and we comment the other behavior just to be sure, to see if we have something, if we can align or not. Okay. So it has compiled, of course, but we don't see anything on the scene. So look like we have an error somewhere. What happens if the acceleration is basically equal to 0? Might end up with some elements. No, we don't see anything if the alignment is to 0. But if we put the steer, so let's try to increase this value. This is strange because the acceleration, if everything is equal to 0, it looks like it's break down everything. It's breaking down everything. But let's try that. I'm not sure I've got the best idea in order to try to implement some flocking. Okay. So now we only get some part of the instance, but not all of them. Yeah. We have some of them which seems to be This is strange. Shouldn't end up with something like that. I'm adding a vector of 0 to the position, and if I'm doing that, you will have nothing appearing on screen. This is quite strange. Seriously? If I only pass the position to the position, we have that? I'm not sure about that. Okay, we have another problem. So, might come to the rotation, which give us some kind of weird behavior. I think it might be the problem. Yeah, okay. I need to remember that we had this little problem on the rotation. Okay. Oh no, I can try. So this would give us the same thing because the vector is 0. So that's okay. And now if I try the alignment, doesn't seems we are moving some of the vector. Let's use the alignment with the separation because we could have elements on the same spot. Okay. Let's continue our little journey here. So the alignment seems to be correct for the description, I think. So let's try to say 1. Maybe it's the problem on the sum here. Trying to understand where I could make a mistake, but let's continue. So let's take the alignment and let's make a cohesion. Cohesion. So again, I need the ID, I need the val, and I need the position. I don't think I would need the val, but let's try that. So the sum vector is at first equal to 0 and the console is equal to 0, and I will go through all the instances. I will take their position, I will take their velocity, that's not a problem, and I need the distance between the elements and the other, and if the distance is inferior to that, I would add to the sum the naive position. So this is it, so this is I didn't rid of that part. And now I can divide by the number of count. And now I can return a seek of the sum. Okay. And for the seek, we've made this. We have a target. So this is the target. I need to pass the position, the val. Also, I need to pass the val here. So of course I will need to retrieve the val for that. Okay. So I still have it. So I need to pass the position, I need to pass the velocity, the max force, and the max speed. I hope we won't reach the point where I wouldn't be able to create this, but let's cross our finger for that. So flow 3 go here. Okay, this is basically equal to the same system here. And now I could say acceleration plus equal go here. And now we would have the 3 vector and nothing happened. Let's try to impulse everything with a little velocity at first. Okay, so let's push a little velocity for everyone. So let's say for the val we would have a random value between -1 and 1. Just to push it a little bit, push it to the limit. Oh yeah, I forgot I'm in a C# and not in HLSL, so I will need to provide the F letter to say it's a float value. And we don't have anything. Okay. So something happened. So let's try to change a little bit the two view to see everything. So of course we have some kind of explosion. So okay, like any force was applied than the one we have here. So for example, if we want to just test the alignment, we would say something like that. Okay, and do we need to scale up the alignment or no? First thing first, I think we don't need the alignment to check, but I think it would be better to check the cohesion. So this is not the way we want it to behave. Not a problem. So look like the force we're computing returns some kind of small value. So maybe we want to change that. Okay. That was the problem. The problem seems to be the distance. Okay. That's what I thought. So now you could see we generate quickly some system where the elements are quickly bouncing and going back to each other. Okay. I could say the same for the separation in order to avoid this little system here. So the desired separation here, it's kind of interesting but to use this one, but I think it would be better to say something like that, and the same we would use a value of 1, and I would not push the size here, so I don't need to recompute that, and I don't need that. Okay, so now I have an error, separate no magic 6 parameter function, because I've tried to push the size into it. So I have proper system here, so that's okay. So the cohesion seems to work, and let's try the separation, the alignment. So I think the separation might be a little bit too big. Okay, the alignment also seems too big. Let's test the alignment with 0.5. Okay, so now they're moving really fast, but they're moving, and the separation of 0.1. Okay, so everything is really too fast, of course, and they are going to infinity. So if we want to try, we could simply check this, okay, and try to see how they behave. They are going on their own path, but this seems correct. So of course we would need to add the global steering behavior, and let's try to see if we have something interesting with that one. Okay, so we have some force that are going to basically collide themselves. So if we want, we need to weight each forces. So now you could see it's a little bit weighted. So maybe we want the cohesion to be a little bit less. For example, we want a cohesion of 0.5. We want an alignment of 0.25, but a separation of 0.25. So let's try that. And we could have some curl also, and the curl would be quite interesting. Because the curl scale might be bigger than the other. So did we push? Let's go back to that. Yeah. Here we are. Okay. So let's think a little bit of what we could try. We could try to put some wall into our guys. So if we put something like 2 and 2, and this is 4, for example. Okay. Let's try a word of 5. Okay. Did we push the word? I think we have pushed the word, but not, we haven't pushed it. Okay. So we need to push the word into our compute shader. So now what I want to make is, because our string behavior is going not crazy, but it's an open world, so every element will try to find its neighbor for a cohesion, an element, inspiration, and up, it's going their own life. This would be basically the same with Daniel Schiffman system. So if I rerun it, we would see it's basically the same. So if we haven't a system which say when an element's going up, it reappears on the bottom, and when it's going left, it's going to reappear on the left, on the right side, we would have something going to infinity and beyond. But we haven't that in Unity, so we need to create this, because Unity is basically proposing us some kind of an open world. So yeah, let me try to use this little variable here that we have already prepared for this first for the first iteration. So it would be the word, and we will push the word. So okay, and now I can create here some kind of a new uniform flow3 word, which taking an underscore and a capitalized W. And now we could make a simple, where is it here? A simple edge system, which is basically really simple, because we will use a modulo. So for example, we will need to say if, not if, we will need simply to say that the position, let me try to, for the 8 is basically simple, because the 8 is simply the position on the y-axis modulo the word dot y, and you have noticed that my word is going also downward below the ground, because it's some kind of a cube. So if I want only to take part on to 0 to the upper to the up of the to the top of the word, it will be 0, 5. So basically we will have a pattern going from 0 to the up. So if it up, it would be 0, and it would be 0. If it less than 0, it could be, I think it would be 0. I think it will not work, but let's try that. Yeah, it will work. It will work. Okay. For the position dot x, we could have something like, and we need to offset a little bit, so it's the same. So we're taking the position to x modulo the word dot y. Okay, so dot x, sorry. So if it reach this part, I need to go back to 0, but remember we have center to the word, so I will need to offset minus the word dot x, so minus the half of the word, and this would be the same, I think, for the c, so for the forward. So z would be that, and let's try this. Not sure about that, but let's try this little guy here. Yeah, it's clearly not the proper way, because as you could see they're going somewhere I don't want to go. Okay, so maybe I could simply create a simple edge system. I thought using the modulo would be great, but this should be giving something on the quarter of the box. Cannot see where is the fucking element due to the plane, but yeah, now is it. So on the Z, that's what I, yeah, we are basically here. Okay, so let's get rid of the plane. So we are going from 0 to the world, and this could be working in fact if I place the element on the proper. No, did I need to offset with a plus value because we're going on the other side? Oh no, we are going, as you could see, we're going on the two sides. So this should be in fact this should be this dot x multiplied by 0.5 in fact. So I could have something going really on the edge. So now we're clearly on the and this should be the same here. By 0.5. Oops. Let's try this one. Good way to try that, it would be to simply not use this, but using only the curl function to see if we are correct, which seems to be. And as you could see, we only are going below this element, so I think we would need to use a quarter of the y-axis to be sure. And now I can change this using plus the quarter of the y-axis. So for this one might be working. What is the quarter of a quarter? Seriously, sometimes I get some strange result and sometimes not, so is clearly strange. Okay, so the main question is, do we go in the proper direction or not? I'm not sure about that. Oh yeah, we've disabled the rotations, that's why. Because it trends to be below 0. And I think that's because if I say I think for the y-axis I need to take the absolute value because of the modulo. Because we are appearing here on the edge, so that's my problem. Okay, so if I take the absolute value of each of that, now you see. Okay, and now I could say something like that. So let me just think about it. I'm not sure about what I'm writing here because I think I would have to change some of the elements. So first of all I need to positive all the values, so that's I'm correct. So that will be taking all of that to saying that plus that modulo of that I think I will go with a proper if else. It might be better because using the modulo is quite interesting, but I need to make some proper computation and I'm not sure about this one. Okay, so let's go back. So if position dot x is less than world dot x multiplied by minus 0.5, it would be then this multi equal to that. Else if would be bigger than that, position.x would be that. If position.y would be that, it would be that. Bigger than y would be this by that. Okay, so let's take this, so we could change, oh, and this was y. Okay, and we would change the y only. Okay, so y, and now we would change the z. Z, and we will make the same here by the z. Okay, so that's a proper if else for an edge, or not a proper one. Forgot to get rid of this little else. Okay, now it seems to be okay to me, and we could recheck the y-axis. So for the y-axis, so if the word is less than 0, then we will go to the top, and if it's upper than the top, we would go to 0. And now we have something, and we could reactivate the plane. Okay, go back to our little system here. If we can get rid of this and say we want that, that, and that, and see what about the rotation? Does it work or not? Not fully, but it's kind of interesting. Oh, here it is. This is a little flocking system. It's not, seems a little bit too much, but as you could see, okay. And we would need to add some steering behavior to that. And if we put that, okay. Let's try the curve. curl is really too big. This is strange because the curl scale is really small, but it's really big when it's applied to that. Maybe because the speed is too much. Ooh, yeah. But the curl speed, the position, because we add that, but I think we can get rid of this one. So this is the position, the curl ink might be something more like that. It's really speed. Which is kind of strange how it's speed. It's always so speed. Even if we multiply this curl scale with some kind of things, but curl noise is really speed. I could set something like 0.1, but I clearly have a problem on this speed value here. This is normalized value, so why? Time, curl speed. Not sure about that. We could repush the element directly on the target, for example. Let's create a new if for that. So if or or for that. For that. Okay, that's the things. Then this could be, we could basically respawn the element to that. So now I'm clearly seeing that the forward is not the proper forward, and I think this would be the Z value, which is not again. My, where is my forward? Why does everything seems to be not going in the proper direction? Oh, it's clearly not working with that. Yeah, and of course I know why. I think we would crash. Please stop. Ah, yes, okay. Yes, this would crash because of this little guy here, and because of that. I just want to see how it's behave if we simply use a curve noise. I always loved curve. It's clearly not the best one, but let's try to think. Do we want to use the flock or not? That's the main that's the main issue. Okay, the flock might be working for thousands of elements. Let's say I want to separate them. To avoid that. Clearly the separation is now too much. We want an alignment of 1 and a cohesion of now we have some kind of a flocking. Could see that. Maybe too big, but we could see the basics of the flocking. So we would need to maybe change a little bit the thing. So maybe we want some kind of, want a big cohesion, but not too much alignment. Trying to understand that. It's really interesting, but okay, let's get rid of that, and let's try to focus a little bit. So we have two possibilities here. We could work with the curl noise, which is really beautiful, or we could work with the flocking, which can be a little bit complicated to manipulate, especially because we don't have some potar to play with. So what I'm thinking about is maybe try to tweak the value for 50 minutes, just to check if we can obtain something interesting. So let's start with the cohesion. You know that the cohesion is okay. Now it's interesting, and we start having some little cohesion. I want to create small groups, in fact. So by that, it's more interesting now. We could see some small groups emerge from that. Okay. Now it's interesting. So 0.5 is interesting. So for the cohesion, so we would have the same for the alignment. Let's try to use the alignment now. So now we have some kind of a flocking system. which is clearly more interesting than what we've got previously. Let's try to use the separation now. I think the separation is the same thing. Might be applying too much element. Ooh, as you could see. So 0.5 or 0.25 for example. So if we put that and the three of them, I know that the same value, but as you might notice, for the separations it seems to be clearly disappearing. So maybe we will keep the same separation which work as we made yesterday. So remember, we've used the size, so that was the idea. So we use that, and we use that as the desired separation here. So let's try that. So I will need to bind the float 3, which is the size of our element. Where is my separate value? This is it. Okay. I have a little things. What's okay? So let's say little bit of a separation for now. Let's add more separation. It doesn't seem to have too much of an impact, which is quite stunning in fact. I'm quite impressed by the fact that the separation seems to be too much. Maybe because of that, so let's say 0.01, so I can basically change this a little bit. Yeah. Okay, now we have something. This distance thing seems really odd to me. It should work by that, but it doesn't, so why? 25. Separation could be more like that. Should be more like that. More than that. So if I said 0.5, everything would be off limit. So it's disappearing. Okay, not a problem. But 0.45, it's disappearing. We don't know why. 0.40. And it's disappearing. Why it's disappearing? I'm really not sure. But this is the same. Divide this and reduce this. Let me go check again the separation method. Okay. So the separate, we have this distance. Okay. We use the distance in the desired separation. That's okay. So this is it. We are here. We take the difference between the position and the neighborhood. We normalize our vector. We divide by the distance. And we add this to our separation vector. Oh, no, this is the same. Normalize. Basically the same thing, but maybe I don't need to subdiv to normalize. But yeah, as you could see, we are losing some elements. The more we are trying to separate them, the more they're clearly disappearing. So why? I'm really not sure about that, because it seems to be correct to me. Maybe because we simply pass all the value we needed. And it's disappearing again. It's disappearing really fast if we wait too much. As you could see, everything is just disappearing completely due to this separation. And then we have nothing. That's really strange. Oh, and we need to remember that we changed that, which is clearly not the better system. Yeah, that's it. So now we have what we called clearly something's too big. Where is my limit system? Yes, this is it. So I was checking that. So the main idea is to say that the vel cannot go in beyond the min max speed. If so, it would be the steering behavior. So now this is kind of correct. And we could change the velocity. Let's try something like that. Vel would be something like flow 3, and now we could put some kind of randomness into it. So let's put a random 3 of the position dot xyz plus the time. Okay, and this plus, for example, the time plus outpost.w, and this plus the time plus the index, for example. So we should have something like a new random vector each time unexpected token kernel, where this is the first random, the second, the third. Oh yeah, forgot this part. So with that we could create a new random vector each time an element is reappearing. So that's okay. So this is the cohesion. So if the cohesion is that, we could also add a little bit of the curl function. Let's try that. So this is clearly not perfect, but maybe this part is not necessary. Okay. Then the curl is interesting but not perfect. So the thing is, now we can focus on the system. So let's try to change our little things and maybe creating some a little bit of a diamond. So let's create a pyramid. And let's put this pyramid on the, so yeah, I was going to C4D, so let me show you. So let's put this pyramid on the proper, okay, this is it. So the size for the X would be something like 10, and the size for the Y would be 10, and oops, not 10, and 10. So let's reset the PSR, and let's say we want the double of the size here. Maybe we want to triple the size. Okay, so now I have something like that, and I will also want to create another one which is going, let's say 5. So reset its PSR also, and create some kind of something like that, you know. And this is it. This is my little diamond system. Push that. Okay, let's take these two current state and deletes. Seems good to me. Now times to reset its little PSR position by taking the origin and taking it to the proper position, and now we could reset the PSR. That's okay to me. So now we have our little guy here. Let's save this. Let's export it to the model in the geo, and let's call it diamond. Now I should be able to import it directly into my scene which is here. So it's not the Daruma, we are now in the geo. Let's take the little diamond, put it here. It seems to be really big. Really big. Okay, where is my diamond? It seems small enough now. Okay, take my controller, take my diamond, put it here, and click play, and I think I don't see anything because the size is too small. Of course it is. So do we put something? We have some rotation here, and I think I want to change that. Okay, so no random position. Or what happened if we don't put all this guy here and see a simple element? We might notice that we are not, it seems we are not on the proper direction for the normal. Let me put some better system. Doesn't look like we are following the normal. Okay, go back to that. Oh yeah, we use that. Don't need that. So now everything is clearly inside. So I need to say we rotate by 90 degrees. That would be better. Yes, it is. It's now better. Okay, we could now say let's take 1,000 of elements and reactivate the compute. Clearly we're not going to the proper direction. Now it's better. Oh, you know what? Let's try to find a paper plane. That would be really better. Let's say something like, I don't know. CG trader. I hope I can find it. So let's say paper plane. I hope I can find something free. Yeah, we have a little low poly paper plane. Oh, this one is beautiful. You can have two of them, in fact. Let's try on Turbo Squid Ortho paper plane. Let's try to find something which is free, and there is 4. This one is free. This one is free. It's not beautiful, this one. Let me check another one. Let's try that. Let's say paper plane and try. Yeah, we have much more that. This could be really beautiful to have something like this one. I hope it has some little texture into it. Let's try that, because it has a little bit of a texture. We can try to color some of it. So let's try the paper plane. Paper plane, paper plane. So first thing first, if we try to simply to see how it's behaved, we can clearly see that we didn't see our little man here, but maybe we can try to increase the number of elements we want in the flocking system. Yeah, 200 might be a good system. And we could also try to reduce the size in order to you can see a little bit demand, but it's clearly not perfect. I'm sure this one would be how can I say that? Clearly interesting, but I'm sure okay, so yeah, it doesn't has any texture into it, I'm sure, but let's try that. Does it as rename it paper plane? Okay, yeah, it has two material in fact. Okay, not a problem. Yeah, let's try that. I will create a new folder and I'll call it paper plane or paper place. Paper plane. Yeah, as I'm starting the art direction a little bit late, let's put the paper plane on the scene. Does it really? Oh yeah, it seems not enough small. Let's reduce it a little bit. Let's say 0.5, 0.25. Let's reduce by the half. I said half, it was a quarter, but I need to be on the half. So let's try that. So yeah. Oh, clearly I need to reduce it again. Okay, so now we can play with some size, so something like 1.5 to 1. And I'm sure the separate would be again a failure. Doesn't seems to fail. Yeah, it's failed. You can see it's fading or not. I don't think so, it's fading. I think we still see everything. Okay, how can we have little guy? I think we have a shader which is ready for that one. I don't remember which one. Yeah, it was the one where we have everything falling down. So if we try to say something like duplicate this little shader, so copy and paste as new, and it was on the which one? we are on the 26th, I think. Yeah, 26. So it was not yesterday but the day before. So let's duplicate this shader. 26 2, and let's try to say that we want something like where is it? Here. So 26 2, and it was not okay, 24 2. Let's try that. So now we have some kind of a paperman. And we could add a little bit of randomness into it, which was that. Okay, and now we could also in the compute shader, and then we would focus on the SDF shapes. This is what I want. Where is my SDF? So this is script. Then we will focus on the shading. So I think I have something like a SD box. So yeah, with a size. Why does I have a size of 2? No, it's a yeah, SD box. Yeah, it's not a size of 2, it's a size of 3. So let's try that. Okay, let's try something like so float SDF box. So the sign distance field of so the main idea here is to get the sign distance field of the box, and by taking the sign distance field of the box I would be able to reduce the size, as also reduce changing the alpha, for example, of this little guy. So it's SD box, and I would take the position, and the size of my box is clearly something like let me think about it, because if I taking the position I would have something like I need the position minus the target minus position. I need the position minus the center of my box. So yeah, let's take the word. So 3, of course it's 0 0 0, but we would have something like this dot y 20 0 half. So this is the half of the half. Target minus location, so this is this is that center box, and the size of my box is clearly a float 3 of the word dot x, the word dot y by the half, and the word dot z, and we will take this as the index. Okay, so okay, so that would be my sign distance field. I could put directly this in the alpha and try that, but before that I could try also to directly put it in the RGB color to be sure. So let's try that. So let's remove all the texture here and all of that. Okay, let's try the size. So size multiply equal to the SDF box, and as I said, I'm not sure about that. Oh, we have a little things here. So it seems to be working on the 8 but not on the half. So why? Might be my position that could be. Yeah, that was that. Okay, so now we could increase the box size, of course, for the first one, for example 4 and 4, but it will get more time to reach the other value. Okay, so because this is reducing, we need to remap this. So let's remap that, and we will use a smooth step. Going from 0 to 0, 1, for example, using the SDF box. I'm going to the fastest way. Which seems to be really not the best. If it's 0, 1, I will get the same things, of course. When I'm remapping this, I don't get the proper value as I thought. Because I think I would need to normalize this value. But the side distance field should be normalized in fact. I've taken this I don't understand why I've got that. It's quite interesting. My sign distance field doesn't seem to work. If I do that, everything is going to 0 because why? It's never going to 1. It's smaller than that. Huh. something strange. First of all, it doesn't seem to go in the proper direction, so let's try to that. If I reduce the randomness into it, I should have something like going directly pointing to the elements, but it seems it doesn't point to the, yeah, it point to the outside, so that's okay. So I don't when I put why does they are going clearly on the wrong direction. Now I have value going up to 0, I'm sure of that. But it's disappearing, I don't know why. Clearly we need to focus a little bit more. Let's take a value of 2. That is enough. Let's add a little bit of curl and then we will try to work on the proper okay. So that's okay. Let's try this part now using the alpha test. go to the free PBR texture on that, and I will go to the paper concrete fabric tile, plastic plaster paint snow. I think that would have something called paper. Yeah, it is. This one, I'm not sure my 3D model has UV. I'm really not sure about that, but if it has, it would be really good. Where is it here? It doesn't know if it has UV map, so let's download our little guy here. Okay. Does the value is below 0? Because we are inside, that's why we are below 0. I think I've understand my problem with the little. Okay. So I need to take here, in fact, the absolute value. Okay. So for example, if I say something like, so this is simply equal of a smooth step of 0, 1, and I forgot the second part of the absolute value of the SD box, because we are inside, and that's something that I haven't think about, but really it seems to be quite logical. This is a sign distance fit into a box, so I know the sign distance fit to the box is here, but when we're inside, it's basically the invert, so basically we are below 0, so that might be the problem here. And that was the problem here. So now we're going from 0 to 1, and if we want to have something going really speed up, so in order to have some paper plane which are more without better size, and now they will start fade out as soon as they reach the edge, so that's better. And this is clearly the same for the alpha tests, so that's okay. So this gives us a little kind of a hope inside that. Okay, and that might be the problem why we need to invert the velocity, because as soon as we add that, as soon as we add the sign distance field to the box, we had to invert the up vector, because the scale was inverted, because it was minus 0. Okay, so now we are that. Let's try to add our texture now. I know it's getting late, we will end up pretty late, I think, but let me try to, because I want to add some color into my little system, but really I'm not sure about how right now. Okay, let test that now. So where is our little paper now? So we need the two elements. Okay, paper are here. So this is the color. We have a displacement, we have a roughness, so this is okay. And we have a normal, so we need to fix the normal. And of course it's a paper, so do we have any, as you could see, clearly it doesn't has any normal texture, so it might not be a problem as we will try to add a little bit of color into it. Let's try first of all to add a little bit of an albedo directly inside of it. The idea is not to have something too glowy. It's not the idea, but clearly it can be really interesting to add a little bit of the color from the cube map. That might be something we want to end up. Okay, then we also have something, I think we still have the ramp. Yeah, we still have the albedo ramp, which could be interesting. So let's try to use, I think, a ramp, a really, how can I say that, pastel color ramp might be interesting. So let's try to use the ramp. So fixed for ramp would be equal to the x to the of the albedo ramp to the float 2 in dot oppose w to 0.5. so this could be our little ramp here. We will multiply by that. And yeah, we add some grain to it, but we could also augment the gray. And let's see if we have some kind of interesting clearly don't like the way. Okay, the reflection here is really too much for me. I don't know why, but it's too much. But yeah, I think we will need to add some kind of metallic to let's say let me think about that. Two things. I think we are too low on the gray value, so that's the first. So that's why we have something really grayish. The second thing is I think we used the gray for the base metallic material when we didn't bind any texture, so we would need to bind one, and we will bind the black one if we don't use any metallic, so metallic would be black. Okay, do we still have something else? It's pretty, yeah, and the main problem with that is basically different things. First of all, we don't have any UV, so that's the main problem. Then we will need to blur really big the environment because it's a paper. Okay, and then I think I could change the ramp, but I'm not sure about that. This ramp is interesting. Okay, so now go back to that, and I think we would not multiply it, but let's try to add a little bit of it. Or if we add that, I'm not sure about that, but if we add a little bit of color, yeah, so now it's really too powerful in the color. We are bigger than one, so that's why. And I don't want to go upper than 1, so let's saturate this. So I want to go to HDR. Okay, I could also avoid having white directly into it, so I would avoid that. So it's less glowy, a little bit less glowy, not so much, but a little bit less. And let's try to add a little bit of the curl. Okay, I think we have it. We have our little guy here. Does we need to have this color? I'm not sure. Clearly not sure about the color. Maybe a simple black and white, it would be the only one with black and white, but I think this color scheme is correct, but let's reduce that. and let's change the intensity to 0.5. Okay, that's it. I think I'm pretty happy with this little guy here. It's not too much, but it's not a perfect one, but we have some kind of little paper plane flowing around, and it's made of paper himself, and we have a little bit of curl with a little bit of flocking, so some elements are following, some are not. Also could have tried to add some noise into it. For example, an idea for changing a little bit the animation here would be to generate a noise to change this part here, you know, to try to modulate the behavior, for trying to add some cohesion and add some separation, and try to create some kind of a dance with that. But yeah, I think we handled pretty well this one. It was not win at the first element, so yeah, I'm quite happy with this. So I hope you like it also, and I would love to see you tomorrow on another Cutvember, and I hope you will find it good, and yeah, let's run this a little more once more and saying goodbye on that. And here we are. So thank you everyone for following me, and have a good night, and see you tomorrow. Goodbye everyone.